Hello, so today we're going to be going over the Routh-Hurwitz criteria to determine stability of a system. And we're going to do this by just looking at the Routh array or looking at the characteristic polynomial Q of S. And in order to determine whether the system is stable or unstable, we must ensure that this following criteria, rules number 1 and 2, are going to be met. So going over the first rule, we must make sure that none of the coefficients are 0, which means that none of the terms in our Q of S are going to be missing. Number 2, all coefficients are going to be the same sign. So they all have to be positive or all negative. If we have, like, let's say positive, negative, or positive, whichever combination, then we automatically know that the system is unstable because we have a sign change, right? Okay, so now we're going to go over a few of these examples to determine whether a system is stable or unstable. Okay, so looking at the first example, we see that Q of S is equal to S cubed plus S plus 1. So going back to our criteria, we're going to make sure that this is going to be met. So rule number 1, no coefficients are 0. So we have S cubed. We do not have an S squared, so we have 0 S squared. We do have an S, and we have like a number, or, which is 1 in this case. So first criteria is not met because we are missing a term here. We have a 0 S squared. So that automatically is going to let us know that our system is unstable due to a missing term. Okay. So next, moving on to the second example, we have Q of S is equal to S cubed minus S squared plus S plus 1. Taking a look at the first criteria, let's check if we have any missing terms. So we have S cubed, we have an S squared, we have an S, and we have a number, which in this case is 1. So, okay, we do not have any missing terms, so first criteria is met. Number 2, all coefficients are going to be the same sign. So all positive or all negative. Let's make sure of that. So we have positive, negative, positive, positive. We have a sign change here. So this means that our system is going to be stable again. So sign change. Or you can view this as all numbers are not the same sign. If you were looking at this in, let's say, like a Routh array, I'm going to make up some number. You have, like, let's say you have like a 1, a 0, not a negative 0, sorry. If let's say you have a 1, a 0, like a negative 1, 0, this would not be met because 2 rules, right? You have no missing terms. You already have a missing term here, and then you're also going to have a sign change. So both of those rules would be just not met. Okay, so once again, this system is unstable because we have a sign change. Moving on to the next one, we have Q of S equals to S squared plus S plus 1. Going over the first criteria, we have an S squared, S, and a number, which is this 1. So no missing terms, so that criteria is met. Rule number 2, all coefficients are the same sign. So we have positive, positive, positive. Okay, all criteria is met, which means that we have a stable system. And that is how you find the stability of system using the Routh-Hurwitz criteria. And a few of the other videos, I will go over an example of the Routh array and how you can determine the stability based on just looking at the first column of this array. And thank you. Let me know if you have any questions.